This is the Fotodyne Gel Electrophoresis box. The wires from the gel box connect to the power supply. The black wire is inserted into the black circle and the red wire into the red circle. The power supply can connect up to 4 different Fotodyne gel boxes at a time. This power supply has a main power cord that has a switch right here. The different controls found on the power supply will be discussed later in the video. The black wire connects to the negative electrode, and the red wire connects to the positive electrode in the gel box. The gel box opens by sliding the lid horizontally. Be careful when removing the lid and do not forcefully pull up at any time. There is a very thin and delicate wire located at the sides and base of the Fotodyne gel box. Please do not touch this wire. When washing the gel box, simply rinse the gel box with DI water and leave it to dry upside down, allowing for ventilation. Next, we are going to add the agarose gel. Make sure the wells in the agarose are facing the black electrode. The agarose gel is a matrix that allows DNA to separate by size. At this point, 1x sodium borate buffer will be added into the gel box. Make sure that the agarose gel and wells are entirely covered by the 1x SB buffer. You will not need to add too much buffer. Doing so will make it more difficult to pipette in the reagents at a later time. 1x SB buffer allows the current created by the power supply to run from negative to positive by conducting electricity. The reason why it is important to place the agarose gel in the correct orientation in the gel box is because DNA has a slightly negative charge, and this will allow the DNA sample to separate in the gel. Please use a new tip for each new reagent or sample. At this time, I will begin to load the gel. You must go to the bottom of the microfuge tube to extract the reagent. This should be about 10 microliters of a sample solution. The first well will be shown as an example of what happens when the pipette tip is not directly over the well of a gel and causes a sample reagent or solution to be improperly dispensed. As you can see, some of the solution did not get placed completely into the well and is now floating in the buffer above the well. It is now possible for this reagent to contaminate another sample. For the next well, the pipette tip will puncture the agarose gel because the pipette tip was placed too deeply into the gel. This will cause the sample to either eject or expel out of the well, again causing possibility for contamination of the other samples. The third example shown is what happens when you push the micropipetter to the second stop rather than the first stop, causing a small amount of air to shoot out, forcing the reagents out of the well. The last example is the correct technique of loading a sample into a well. If you were to shake the gel box after the reagents have been loaded, this will force some of the reagents to be disrupted from the wells. Therefore, it is important that once you begin loading the gel, do not move the gel box. When finished loading the wells, carefully slide the lid back into place. At this moment in time, we will turn on the power supply. The buttons shown are Run, Pause, Voltage, and Amplitude. Make sure that the light is on for voltage. To adjust the timer, click the upper left button so the light next to a clock symbol is lit. The timer must be set to 20 to 30 minutes. Next, the voltage must be set to 135 to 150 volts. Please press Run after the settings have been set. To make sure that the settings have been set properly, you can click this button to view the settings. The gel box will begin to cloud over as it is running. Thank you for watching.